So basically she's gonna
legible.
jump off of this.
How far below the bridge will cave actually be hanging once she stops escalating? It comes finally to a rest. Assuming that she doesn't touch the water. I don't know if I could go bungee jumping.
I don't know either. Seems like it'd be fun, but
Whatever, it's just free fall.
freaky. So she's just got a mass N, a surface. Her mass is M, and she's at height H above the water. So it's just an energy problem. Is that everything else? Everything?
Yeah.
Yeah. Okay.
Then
Use
G
G.
for the magnitude of the acceleration due to gravity.
That's what we're gonna do anyway. So this is before. And then after. Should just kind of be like. Let's make that same height. You'd have this bungee cord. Should just be hanging somewhere in here. Okay. And then it's asking you how high it should be
At rest.
right here. You just find an equation for it. So right here, what's the energy that she has?
Nothing, hardly. Gravity.
Yeah, just gravitational potential energy.
Yeah.
So what's the equation for that?
Gravity. MA.
So that'd be the force. This time it's mg times the height, right? And then what kind of energy does she have when she's down here? She's just hanging there, she's not moving anymore.
This is MGH. Yeah.
So let's call this
Gravity.
d. So mg, and then her height will be this new distance, which is what we're trying to find, right? Where did this energy end up going?
The MGH.
Yeah, so she started out with this much energy, she has to end with that much energy,
Right.
but we know she's lower, so some of that energy went somewhere else. So what happens when you bungee jump?
Well, it cancels some energy out. Right.
Yeah, so the bungee cord stretches like a spring,
Yeah.
so there would be some elastic potential energy.
Yeah.
Because if there wasn't gravity and you had that bungee cord stretched out and you let it go, she'd shoot back up, right?
Huh. So the energy went into the bungee cord.
Mm-hmm. Yep, because if the bungee cord wasn't there, all this would be transferred into kinetic energy and she'd just fall and hit the ground. But in this case, it was transferred into kinetic energy and then it slowed her down by stretching out that spring, right?
Right.
Until it stopped her. So this will have spring potential energy, which is 1/2 Ks squared. So let's see, it'll tell you how long.
Bless you.
Hmm. Okay. So we know, well, we know mass, we know gravity, we know h. So we'd end up with an equation that looks like this, right? mgh equals mg d plus 1/2 k s squared. So that's just conservation of energy. So we know those three, we know those two, and that's what we're looking for. And then we know this one, but what about the distance that the spring stretched?
Don't know that yet, do we?
No, so we need to find a way to figure it out. So how long was it originally?
The bungee cord,
Yeah.
it's just K.
That's
The
the
spring one.
spring constant.
Okay,
The length was
just length, L.
L, yeah. So if you go from here, there's a point right here. If it hadn't stretched at all, this would be length L, right? And then she's actually being treated as just a point. So we're not worried about her height. And then we have this distance, right?
Right.
Which is what we're looking for, so we can use that if we need to. So this right here is S.
Yeah.
And then this full distance is H. So from that, what's an equation for S using just H, L, or D?
Equation for S.
Yeah.
So it would be D plus L. We want to have S equal. It'd be like D plus L plus S equals H.
So you could put this, H equals L plus S plus D. Then you solve for S.
Yeah.
So H minus L minus D equals S. You put that into this. So you have MGH. L is H. And you have to solve this for D. So I guess we just have to square that.
We
Let's see.
get MGH equals MD, MGT plus 1/2 K, and you said you'd square it, so it'd be H squared minus L squared minus D squared, is that what you're saying?
No, because it's this, right?
Oh,
So you have to do h times h is h squared, h times negative L is negative LH.
You have to fold it.
Yeah.
Fold it.
So you have that, the negative L, so this is plus L squared. Negative L times H minus LH. Negative L times negative D is plus LD.